So next method which we'll be using, next property which we'll be discussing is called as the impact strength. So far we have discussed three major categories. One is the tensile strength, compressive strength. Then we discussed about the hardness. And now we'll move on to impact testing. So what is impact strength? Impact strength is otherwise called as toughness. So toughness is the ability of the material to withstand impact. So when a sudden load is applied, how the material reacts. Imagine you are striking a metal plate with a hammer. The material is ductile. What happens? It may bend. If it is a brittle material, then it will crack. So that defines the toughness of the material. So again, the materials which are hard and high strength. So materials which are hard and having ductility, ductile as well as hard materials will have high toughness compared to brittle materials, hard and brittle materials. So if material is hard and ductile, it will possess more toughness than a hard brittle material. So shafts, hardened steel shafts possess toughness. Shock absorbers. So they are subjected to sudden load. That's the purpose of shock absorber. It should absorb the shock. The springs inside the shock absorber suspensions will have high toughness. That's inherent property of those materials. So how to test the toughness of material? We'll see now. So there is a impact testing machine. The test actually is called as Charpy testing. This is similar to your UTM machine. So here there will be a hammer. So like this, as you can see this image, there will be a hammer which will strike the workpiece to measure the impact strength. The load at which the specimen breaks, that is the impact strength of the material. So this is actually based on the working of a pendulum. So when you suspend a pendulum in a higher position and release it due to gravity, what happens? And the acceleration due to gravity, it will come down at the higher pace. So when it strikes, it will be the mass into acceleration due to gravity. Sorry, weight into acceleration due to gravity. So that's the impact in terms of Newton. So imagine you are having a 10 kg hammer and it is striking the workpiece. So what will be the load? It will be the weight into acceleration due to gravity, approximately 100 newtons. So that's the load which we are applying. So what happens in an impact strength is this. It strikes at 167 kilojoules. So it's based on it's calculated, as I said, based on the size of the hammer, weight of the hammer. So here a notched specimen is used. So this is an important part. Why we are using a notched specimen is that if it is a ductile material, then it will not break easily. If it's a brittle material, it will break easily. But if it's a ductile material, it will bend, it will not break. In order to break the material, we are making a notch. It's like cutting the tree. You cannot cut the tree directly. You have to make a notch. And then if you cut from the other side, the tree will break easily on the notched end. Similarly, this principle is used to cut the workpiece into half. The load at which the material is cut into half, so that is actually called as the breaking point. So there are two major types of testing process. One is impact Izod testing, another one is impact Charpy testing. So the major difference between both these things is that in impact Izod testing, the workpiece is kept in a vertical position. If you go for the Charpy test, the workpiece is held in the vertical position, and also the striking force, if you can compare both things, Izod test has a striking force of 167 joules, whereas Charpy test has a load of 300 joules. So based on the based on the cutting load, we can determine the toughness of the material. As you see here, this is actually an aluminum specimen which is being cut into two pieces. So from this, we can measure the toughness of the material. Thank you, students.